Good afternoon, everyone, and thanks for attending today's presentation regarding generator fuel oil pumping and distribution for New York City. My name is John Haber. Any questions, please enter them in the chat box, and we will answer them as best we can at the end of this presentation. Thank you. Okay, so today we're going to talk about fuel oil handling, fuel systems, primarily regarding diesel generators in New York City. We will discuss layouts, conversions, pump terminology. We're going to touch on the basics for pumping, application examples for the generator. We will have discussions with the fuel system layout, unit conversions, terminology, fuel oil pumping basics, and we're going to touch on different applications as well as long-term storage and code caveats regarding New York City. Here is a layout of the type of equipment you would see in one of these installations. On the lower left is a main oil tank that's buried with manholes to access through the street or parking area, feeding into a mechanical tank selector valve that would be used on multiple tanks. We also could use motorized ball valves here as well. Feeding your duplex pump skid up your riser and into your remote day tank through a piping manifold if there's room for that. Also, you may see the filtration unit for larger oil tanks and different types of fill boxes. For instance, this is a wall type here. And then over in the lower left is the in-ground type. On the left is a product legend. You can use the number that's referenced and find your page in the catalog 26 to get further information on that item. We're going to discuss some standards for pressure and vacuum. Pressure 1 psi is 2.31 feet of water, and 1 psi of number 2 oil is 2.6 feet. So water is a little bit heavier. There is vacuum. 1 inch is 1.28 feet of number 2 oil and 1.13 feet of water. Perfect vacuum is negative 29.92 inches. Some pump terminology: NPSHA, net positive suction head available. This is the absolute pressure available at the suction port of the pump, and it's a function of this system. You also have NPSHR, your net positive suction head required. This is the minimum pressure required to keep the fluid in the pump from boiling or flashing, which would cause cavitation. And that is a function of the pump. NPSH and cavitation: high velocity, low pressure at the suction side of a pump can cause the fluid to start boiling and cavitating. You're going to get reduced efficiency and gear damage on your pump. Boiler and cavitation starts when the pressure in the liquid is reduced to the vapor pressure of the fluid at the actual temperature. So to prevent cavitation, your NPSHA must always be greater than your NPSHR to prevent cavitation. And the photo here shows a low pump gear with some damage done to it. Here is a typical gear type pump rotating. You'll see these dark swirls here. This is air entrainment in the system. This is not a big issue here, but if there was an issue, you'd see a lot more of this bubbling action. So NPSH and cavitation: as long as your eye of the pump is above your vapor pressure, you will not have any problems. So why positive displacement pumps? For most practical purposes, you're able to pump viscous fluids. They are self-priming, although we do not recommend they be self-primed. We prefer to have oil primed into the system at startup. These pumps are able to lift fluid from a buried tank and you'll have a vacuum operating on the suction side, and we do not recommend you run these dry. Discharge flow is constant over a range of operating pressures and viscosities. So pump and motor selected for the system are going to be sized for this particular job you're doing, and that range or that rate will be constant over the years. You can develop high pressure, and if there's a blockage in the system and there's enough horsepower in the pump, it will continue to run, and then eventually something in this line is going to break. Pump motor combinations produce the fixed flows, so your pump will determine your flow by the motor RPM, and the horsepower will determine your capable pressure. On the discharge of every pump is a relief valve, because most pump and motors will have isolation valves on the inlet and the outlet to isolate it for maintenance. So in between the pump discharge and that shutoff valve, you will have a relief valve to be able to bypass if there's an issue with blockage in the system. This is a typical pump curve. So if you're looking for a pump curve, you'll notice here lines are relatively straight. You're going to pick an RPM, a horsepower, and that's going to give you the flow rate required for the system. Here's a typical fuel system serving a belly tank on an upper floor. You will have your tank, which may be in the basement, along with your pump skid, your riser running up your building into the generator's belly tank. You'll have a level sensor communicating with the pump control panel down here. The panel also will interface with this tank, monitoring level, leak, high and low points, and gallons display. We also communicate with the overfill alarm that may be in a wall-mounted fill box, for instance. And then with this rigid pipe system, you'll have a drum at the bottom, monitoring and collecting any leaks that may occur. If there's any horizontal offset in this building on an upper floor, and if it's longer than 25 feet, then you're going to have a sensor at the horizontal run near the riser where it's running back down into the oil tank. This is a remote day tank on a generator. Again, we're feeding into a main tank from the street. This particular job may have a larger tank, so there may be a filtration unit piped into this tank. And what we like to see with filtration is a suction line at one end of the tank and then return to the far end of the tank, so that you can get good circulation through this tank when that filtration unit is running. And again, your pump skid is piping up to your generator day tank and being monitored by a sensor. We prefer not to combine this pump and filtration, because if something happens to this filtration unit, we do not want it to impede the function of this pump, because this pump is what's feeding your generator day tank. Here's a header system, perhaps on the first floor of a building. This is a good installation in lieu of a day tank, because this takes out any requirements for venting that day tank. You can certainly use a day tank, but what would happen is you would overfill the day tank before the oil would flow back to this main tank. And typically your main tank is much taller than the day tank, so you've got some head pressure the day tank has to be rated for. We also are able to fill from the street above the fill box. If you have what we call a pressure fill, we pump into this tank to fill it up. We have different types of pumps used for different types of applications for filling generator systems. This first type is an internal gear pump. It's two mesh gears, one driven, one idling. The outer driven gear has internal teeth. The inner gear has external teeth. They're good for rates approximately 20 to 1,000 gallons per hour, and typical pressures up to 100 psi. It's low NPSH requirements and has low to very high viscosity. Here are the inner workings of a gear pump. You can see the fluid being pulled in by vacuum through the gear and out the discharge side. Here is our external spur gear pump. These are used for higher pressures and higher flow rates than an internal gear pump. So they're two mesh spur gear and external tooth gears, one driven, one idling, synchronized by timing gears. In general, it's low to medium flow rates of 10 to 40 GPM, and the pressure's up to approximately 250 PSIG. Again, low NPSH requirements and low to high viscosity. The other pump we use is a screw type pump. These are more of a high-end pump used in perhaps central heating plants, very large data centers, or surgical centers, large surgical centers. Extremely rugged, and pressures from 200 to 500 psi, very high flow rates, 20 to 100 GPM plus. And you'll notice this design is a little different than the internal gear or spur gear type. It has a 3-rotor screw pump here. Different fuel system applications. Generator systems may have day tanks, they may have headers. Most common is a duplex pump skid with 2 pumps rated for 100% capacity. One is backup, and we auto lead lag those pumps so you get even wear. Triplex pump sets for larger plants. You may have 2 pumps that are running, and then the third pump may be a spare, it may be backup. In a situation where you have an overflow situation. And then other types of pumps are jockey pumps, where you may have a large tank farm and facilities may want to move oil from tank to tank because they may have a favorite they use. Also, there are pumps on day tanks, but not in New York City, and filtration systems have pumps on them as well. So day tanks used for remote inventory, for diesel generators, maybe remote burners and boilers, hot water heaters, whatever fuel burning device you have remote from your main tank in the basement. It decouples that device from your main tank and from your pump skid so that there's no pressure put on the inlet to that appliance's pump. Gives you some extra protection, so if something happens with the pump in the basement, that they have a few hours upstairs to run that device, that appliance, while they perhaps repair what's going on downstairs and get that pump skid running to, again, top off that day tank. You can have 2 to 4 hours of runtime. That's typical up at a generator for a day tank or a belly tank. Headers are a little different. Headers, the typical runtime is 3 hours of runtime. And you need to be careful with foaming. So we want to have drop tubes in the tanks or headers to prohibit that foaming. Diesel will foam rather easily. Overflows and leaks from day tanks, they're costly mishaps, and we want to avoid them as much as possible. So some day tank considerations when sizing for a generator. Usually 100 kW of generator capacity consumes 7 gallons an hour. I've been using that for many years, and it hasn't really deviated. There's a large difference between the generator burn rate versus the actual pump rate. So the generator is going to pump a lot more fuel across its injectors to keep them cool. Unburned fuel will cycle through and return back to your day tank or your header. So you want to make sure in this instance that you're staying ahead of the consumption of the generator. If the unburned fuel was returned direct to the main storage tank in the basement, bypassing the day tank, then you would have to base your pump skid downstairs based on the consumption the generator is rated for. Generator fuel oil return piping, you have a day tank, Upstairs gives you the few hours. Sometimes they're small based on the fact that there may be existing systems on a certain floor and you can only have a limited amount. So returning fuel from a hot generator may be too much for a small day tank to overcome. Typically, though, the generators will have a cooling radiator to cool that fuel before it enters into that day tank. If not, then typically we recommend just return to the main oil tank in the basement. Typically, our duty cycle for pump sizing is 4:1. We want to give you plenty of space for this pump to get oil into the device when it's needed. Here's a typical schematic for New York City. You have your tank in the basement, your pump skid down there as well. This tank is vented outdoors, so it's a zero pressure operated tank. You pump up your riser. The generator starts, it consumes oil from the day tank, it returns to the day tank. And once that level hits a preset, it will refill from the pump skid downstairs. If something happens and oil were to, for some reason, go up the vent, we have a T connection per code, which will connect to this overflow pipe and return safely back downstairs. There is a requirement now in the 2022 code to have a sensing device in the vent line. I like to put it above the T so that the system, even though it's in an overflow situation, it can continue to run as needed. This return line is actually now an overflow coming out of this day tank, and it shall be 2 sizes larger in diameter than the suction, than the pump supply line. There are different types of tanks used on these jobs. UL 142, which is fine if you're on the upper floor. But in the basements, we typically use a New York City alternate tank design. It's the most common tank. Buried tanks can also be 25 PSI rated. There's a section of code 1305.7.4 that tells us that the tank must be rated for a filled vent line. So whatever this head pressure is from this vertical line, this tank must be rated for that. 12 vertical feet is 5 PSI, and that is your maximum pressure rating of a UL 142 tank. This is a belly tank mounted under a generator, also a day tank. UL 142, so you have emergency vents on the primary tank. This basin around that belly tank has a vent sense on it too, which is in this case a combined vent. You can combine all your vents and run that to atmosphere with your sensor in your line here. They can also run separate, but your main working vent will connect back to the overflow line. This is a remote day tank in a generator room on an upper floor. You have multi-point level sensors in it communicating with the pump skid control panel PLC for automatic operation of the system. We also have leak detection in it as well. This is your typical sensor with a low, a pump on, a pump off, and a high level set point. Typically 40, 50, 80, 90% is what they're set at. This is an emergency vent here. This would not be allowed in New York City. This vent would run to atmosphere and have that vent line sensor in it. You can also monitor for temperature if you have such a small tank and a larger generator and just no avenue to return that hot oil anywhere else. You have your secondary containment around this day tank. It can be an open top, and this will be 200% capacity of the supplied day tank. And then, of course, outside of New York City, you could have return pumps on these day tanks. Here is a header system for a generator. It's just an oversized piece of pipe. It will be schedule 40 per New York City code. The larger in diameter you go with this pipe, the heavier it's going to get because the walls get thicker as the diameters get larger. But you're going to pretty much use the same components. You come into the room with a shutoff valve, a fire valve entering your header. Your generator is going to have a foot valve, pipe through, and then return. There can be a sensor on it to monitor it for low level, and this will activate the backup pump if this is activated. Typically, when these systems are piped, this header should always stay full of fuel. The pumps, as I mentioned, are rated for much more capacity than the generator is going to consume. So this should always really be full. And if for some reason this activates, it's either something happened to the switch or maybe the pump failed out or something else. But we like to pipe in where the fuel enters the header through the generator and back to the far end where the return connection is. In this case, this is a return line. So that hot oil coming back that's introduced back into the header can be pushed through and back downstairs and cooled through the system and into the main tank. We also show a vacuum breaker here, which is piped into a drum, and the drum has a breather to allow air in. Usually systems over 20 feet high, you would want to have this vacuum breaker to break this vacuum created when your supply pump stops. Oil is still falling back down to the basement tank. If you didn't have this, you have a good chance of this oil falling to pull the oil out of this header and drain the header out, and there's nothing you can do because when this generator is off, the pumps are not allowed to run. So when the generator, the next time it went to start and this header was empty, you're going to fail out. So having this vacuum breaker here will allow air to enter the return through the drum and the breather and break that vacuum cycle right here, allowing the oil to finish falling back down to the main tank and leaving this oil in the header. Headers are allowed to be up to 330 gallons, but beware that on smaller generators, I've seen issues where they've rejected larger headers. They prefer headers rated for 3 hours of generator consumption. Pump inlet suction guidelines. This is really the heart of the system because if you can't get the oil into the pump, then you're not going to get oil anywhere else. So we want to keep our pumps close to the oil tank if we can. We want to try to avoid long suction pipings or inverted loops. We want to operate about 15 inches of vacuum or less. That would be optimal. Gear pumps can produce 20 inches of vacuum. Your piping losses may be 2 to 5 inches on systems. So that gives you 10 inch for static lift, about 12.8 feet of oil. And if you operate continuously at 20 inches of vacuum, you're going to get some premature pump wear and failure. So we want to keep the pump not more than 20 feet above the bottom of the tank. I recommend vacuum testing all suction lines because this pump is actually operating in a vacuum. So we'd like to imitate that prior to putting the system into service to make sure that there is no issue with your piping installation. And oversized pipe can pose a problem when you're running with a low rate pumping system. So determining inlet suction, we want to have the gravity feet of head of oil, determine your losses through your piping, static lift from the bottom of the tank. Now beware when you're looking at this portion of a very tank job, it gets disconcerting sometimes when you're looking at the bottom of the tank and you're at 18 inches of vacuum and there's concern, but when you look at it as a tank that's full, then you're at 12 inches of vacuum and you're in a good operating parameter. So Um, when they get down to such a low vacuum and such a low level in the tank, then they've got other issues that are going to be more concerning than just the pump running in that high vacuum. Um, you got to convert your fittings and your valves to equivalent feet and add your lengths of pipe and loss through the strainer, and then you'll have the total inlet suction requirements. And if for some reason you have a high vacuum, perhaps you can increase your pipe diameter or reduce the amount of fittings that are in it, and try not to oversize the suction piping. Now, these pump skids feeding generators are typically installed in a room that is unmanned. Most of the time, thankfully, they're monitored by BMS, but for the most part, you want this system to operate when it's supposed to operate. So what we have is a three-way motorized ball valve with end switches that we use. And being that we're serving a day tank, we can't just run the pump every day and and test it, because we'll just overfill the day tank. So we use the motorized ball valve in the discharge, and we'll bypass the day tank and return back to the main tank. Therefore, we're testing the pump motor and prime on each pump on the duplex pump skid, proving their flow, sending a signal to BMS so they know it happened, it was tested, and it works, and they're good to go. So that's a nice device to have, and it's becoming more and more standard on these systems. Now, I mentioned earlier about the suction side and your piping criteria and what to look out for. So buried tanks, for instance, you're always going to have a foot valve in the bottom of the drop tube in that tank. That's going to hold your prime all the way back to your pump skid. There are times where we may recommend a check valve also in the line if it happens to be an exceedingly long run. But you'll see here I have a tank buried 4 feet below grade, we'll say before 4 feet below the pump, 8-foot diameter tank. We're still at 13.91 inches of vacuum, and that's a good operating system. Now, this pipe sizing program is on Preferred Utilities website. You can go on and use it anytime you'd like. Again, so what we have here is we have our pump information, our pipe diameter that was selected, your viscosity, your losses through your system, and then your total pump suction is indicated here. That's a good working system. Available is 19.51 feet of oil for your NPSHA. Your required NPSH is 5.5 feet, so we're well above the requirement. We have our discharge line here at 1.5 inch diameter, some end pressure at 3, minimal piping losses, a discharge pressure of 8.78 psi. And then our indication here of our priming velocity, 2.05 feet a second. Good operating system. Here is a system that's at grade, your tank's at grade, your pump's at grade, but you notice we're at 14.25 inches of vacuum. So why such a high vacuum? It's this anti-siphon valve. So the point of this valve is to prohibit any breakage in this line from draining the oil tank out onto the floor. So this this anti-siphon valve is going to take a lot more vacuum to open it, so that it's a good working system. Here's a review of a system with that anti-siphon valve in it, and you'll see your pipe diameters, your viscosities, your friction loss, and then here's an anti-siphon valve loss of 10.64 inches of vacuum. So there's no way, if that pipe breaks at the floor, that natural vacuum is going to pull that valve open and drain the tank out on the floor. These positive displacement pumps can make 20 inches of vacuum. We've mentioned that. This is not an issue for the pump as well. Here's your friction losses through your strainer, and you're at 14.25 inches of vacuum. That's, again, a good operating system. We're well below 15 inches of vacuum. Our discharge line is indicated here. We've gone up, we got 46 PSI of static head, so we're going up to an upper floor. And our velocity shown here, 1.24 feet. Here are typical pump skid components. We have our two pump and motor assemblies, 100% rated for the system, your duplex oil strainer, a differential pressure switch on the strainer to let you know if that basket gets dirty. Somebody can go over and just move the handle from one side to the other. Even if the pumps are running, it's not a problem to get the clean basket in use. Here's a isolation ball valve on the suction side, isolation ball valves on your discharge side, relief valves between that ball valve and the pump outlet. That'll be piped back to your oil tank. Here's your pressure gauge. And one thing you want to look at is this compound gauge here on your suction side. Are there any issues with your system? This is one of the first things you're going to look at. What is this reading? If it's pegged down on the vacuum side, then you've probably got some kind of blockage in your suction side. This pan is turned edge welded, and in the back, which you can't see, is a leak detector. Control system considerations. Starting and stopping the pumps automatically is a big consideration for these systems. They can be very simple. They call for operation from a boiler or a hot water tank, heater, or something of that nature. We've got intermittent operation for day tanks, headers, lead lag alternating schemes, whether it's the pumps on the pump skid or perhaps a bank of main oil tanks in the basement. Just pressure and temperature monitoring if needed, and sequencing motorized ball valves for tank selections in the basement. Of course, we have our automatic backup, so if the lead pump fails out, it's going to be monitored with a flow switch, and that allows the backup pump to automatically start. We'll get alarms for any malfunctions. We have that automatic texting capability and safety shutdowns. Some could be as per ownership, others are required by code. Here's a large data center that shows you some capability beyond a typical boiler loop. This is a system where it actually interacts with a very similar system in another portion of the building that looks exactly the same. This is your typical communications ports. Like we say, we could have vent sensing, your pump flow monitoring, all that, day tank controls. We've got that covered. We've got the cloud available. So if you want a secure server to monitor offsite, this is a great option to have. So typical flow alarms or fuel oil systems alarms are pump failures, total pump failure, your day tank levels, high, low, overfill of main tanks, leaks points, whether it's the riser or the pump skid, or if there's oil going up your vent line. So that sensor in the vent, that's going to be your last line of defense before oil goes out that vent to stop the oil pump skid from operating. Dirty strainers, of course, PLC failures, motorized ball valve misalignment if something were to happen. All of it's monitored through our systems. So in New York City, we have a mechanical code we have to follow. There are some points in this code that absolutely have to shut down the pump skid. Your riser leak sensor, your day tank leak sensor, the vent sensor in the oil line as well. All right, so types of oil carrier pipe, we're going to use Schedule 40 seamless, ASTM A53 or A53M for your supply, your return, your overflow, your vents, your fills. If If you're in the pump room, it's threaded pipe. That's quite acceptable. Once you leave the pump room and you run out and up your riser, that's all welded. When you get out on your rooftop, you're going to be welded and double wall containment up to within 72 inches of your appliance. Anything over 25 feet horizontal will have a leak sensor in it. Your riser is going to have a leak sensor. If you're using the other more common pipe these days, which is the double wall flexible, you're going to put a vacuum panel on that. There will not be any other leak sensor in the system, which is nice. And this piping would be a home run from your day tank on your generator all the way into your pump room. This is double wall, so you see here 2 walls of stainless with an outer coating to protect those walls of stainless as this pipe is run through your building. Our typical connector is the threaded type here. Something to talk about regarding all the oil storage in your basement. This is organic. It begins to decay as soon as it's left the refinery. And it can sit in this oil tank for many, many years. And diesel is quite prone to degradation. You're getting moisture entered into that tank from day one. That vent line runs out to the street. It may be a day where there's condensate buildup. There's condensate buildup on the inside of that pipe. And the way that we pipe our vents, they have to run down into the tank, and that water will run down into the oil tank. With that happening, you can get too much water in your tank. You're going to get a bacterial growth. It's going to clog filters, clog injectors on generators. It's going to reduce the cetane rating in your fuel oil. And between 2 to 5 years, you could have a major problem with your inventory. So you have to maintain this oil at as best you can. And another item about this is you're going to get hot spots on your tank inside. So there are manufacturers who weld the inside of the tank. All those seams are open. It's nice to weld them and seal them up so you don't have those hot spots where this oil and water can have that bacterial growth and acidic effect on the steel. So your water collects on the bottom. Between the water and the oil is your bacterial growth. You're going to get your hot spots on the side of the tanks, wherever this is. Your pump has a foot valve. The foot valve is down here near the bottom of the tank. So we're pulling that in to your fuel system and introducing it to your generator. Monthly testing of this fuel oil is not going to pull enough of the fuel out of this tank to keep it fresh. You're going to want to either filter it or turn it over frequently. This is a typical filtration unit for a tank, up to 10, 15,000 gallons. We filter down to 5 microns. There's water removal. And your inventory in your tank is going to determine your filtration size. Here's a skidded type system. This may be for a bank of 10,000 gallon oil tanks. Again, filter down to 5 microns. We're going to remove oil. We're going to add chemical treatment. We're going to have automatic controls in the system. This system or the other system, we're going to double the life of that fuel oil and give it the longevity it needs for these generator systems. Of course, you want them to always start reliably. And again, inventory determines your system design size. All right, so New York City has a code. Everybody may not be happy with it, but you know what? It's a pretty extensive code. It touches on a lot of what you can and cannot do. So I wanted to run through some of the more common points in code with these caveats. So your tanks must be designed for the maximum static head from a filled vent line. That's an issue. 12 feet, 5 psi. That's your max pressure rating of a UL 142 tank. That's why Most of the tanks that go into basements are the New York City alternate tank design 25 psi rated. Your day tanks are typically above the lowest floor. You have to have a containment basin around it that's rated for 200% capacity. 330 gallons is your maximum amount of storage above the lowest floor. UL 142 tanks, you've got venting because you've got emergency vent fittings involved. The alternate tank design, we do not require emergency vent fittings on those tanks. And again, with main tanks or day tanks, same type of tank can be used. Up on the upper floors, UL tanks are fine. You know, they're a low pressure point of the system. Usually the vents are rather short. Be aware that the new 2022 code states the vent on a day tank must terminate 8 feet above the overflow line. One day tank, one pump skid, one piping circuit. That's it for New York City. If you're going to have multiple day tanks on a upper floor in the same room, they're going to each require their own pump skid and piping circuit. Any tank over 660 gallons in your basement, the fill box used to fill that tank will require spill containment around it. And your riser requires leak detection. That 55-gallon drum with a sensor in it is going to stop the pump if it sees oil. Anti-siphon valve when the tank elevation is higher than your pump inlet. A foot valve when your tank is below your inlet to your pump. And your fire valve, now this is another new change in the 2022 code, is every pump skid has to have a fire valve at the inlet to it. The rooftop enclosure requires a fire valve at the inlet to it, and then every fuel burning device, whether it's a generator, boiler, hot water heater, whatever it is, they all require a fire valve at the inlet to it. Some other caveats: double wall metallic pipe with continuous vacuum leak detection is in the code, and you can use it. We touched on the larger tanks. Locations of fill boxes: 2 feet from any building opening, 5 feet from any subway grading. Your vent 2 to 12 feet above your fill terminal. 2 feet minimum, 12-foot maximum, and again, keep them away from building openings, minimum 2 feet, and make sure they're in a non-hazardous area. Now, if your vent is not going to be visible from the fill terminal, the new code states that you can have an electronic overfill alarm system at your fill box, or run a 1-inch telltale line into your fill box. So that's nice that they now allow you to have the electronic overfill alarm. Typically, it alarms at 90%. That gives the guy filling the tank enough time to disconnect before they overfill it. Pitch your pipes back to the main tanks. No sags, no traps in this piping circuit. On the suction line to the pump from the tank, you're going to have a shut-off valve in it to isolate that tank if need be. And again, day tank vent to terminate minimum 8 feet above the overflow pipe, direct to the outdoors. And you'll have a sensor above that T-point where that vent has to connect back into the overflow bypass. The overflow line coming off a day tank must be two pipe diameters larger than the supply line feeding that day tank. Headers or loop type systems can be the same diameter as supply in return. And again, horizontal runs over 25 feet are going to require a sensor prior to that horizontal portion feeding back into the main tank riser. All right, so in review, problems that occur, we want to be cognizant of the suction side of the pump skid and making sure, we're going to get oil into it. Loss of prime is an issue. These systems sit and they sit and they sit. They're run perhaps once a month to meet the testing requirement for many, many months before it actually may be in operation for an extended amount of time. Venting is an issue for tanks. And code. So, we have a great code here in New York City to follow. May not always be clear, but we can always ask questions. And I have this caveat sheet available. Fuel oil storage, long-term storage with large amounts of fuel can be costly. And I appreciate everybody staying and listening to this webinar, and have a great afternoon.
Okay, Megan, are we live now?
Yes, we are.
Okay, so I'm Dave Oaf. I work with Preferred Utilities, and I do a lot of these webinars, and I agreed to help John out with the question and answers. Megan, do we have any questions from participants?
We received one question in the chat, which is, what is the link to download the catalog with the legend of components that was shown earlier in the webinar? I believe John Haber mentioned in the video that it was on a Preferred's website. And then where can we download the flow diagram?
Right, so that's something I have in probably the ACS library. I can get that email to them.
I think the best thing to do if somebody wants more information is to email John Haber, and he put his email in the chat. At least I can see it in the chat. It's jfhaber, Haber at acs-ny.com.
Here's a common question that people do ask since we're live. Does my fuel system have the ability to connect to BMS? And the answer is yes, we can connect via Modbus or BACnet. Both options are in the control panel. And to follow up on another question that was asked outside of this, can I have a return pump on a day tank? Not in New York City. You would literally have to overflow the day tank and pump through it to get back downstairs to the main oil tank. And being mindful that in this scenario, all your lines will equalize, so your vent line as well is going to fill with oil. Bear that in mind when you're designing the system, and we give that vent line a height so that we don't have oil going out of the vent before it goes back to the taller main tank.
John, can you do an overflow line and a return pump in New York City?
No, you can not have a return pump at all in New York City.
Wow.
You have to return by gravity. That's what code requires.
I've seen schematics for systems. They must not have been in New York City, where you'll have an overflow line that's gravity, but then there'll also be a dip tube with a return pump, and the return pump will tee into that gravity return line. So that's verboten in New York City also?
Yes. So anywhere outside of New York City, I've seen and designed systems with return pumps and bypass. But in New York City, again, there's just no allowance for return pumps on day tank systems.
Okay. A lot of people in New York City are talking about switching their boilers over to burn biodiesel or B100. Does anything you covered today change if the fuel is B100 instead of number 2 diesel?
Yeah, I think first and foremost, you're going to heat the fuel that's now stored in your tanks, and you're going to want to You're not going to want that oil to just sit if it's a standby fuel. If you're on primarily on gas and this B100 happens to be backup, you want to at least have the ability for the pump skid to automatically cycle through this tank for 15 or 20 minutes a week, just so though you don't get this settling and separation of the B100 fuel makeup. So that's probably the tip of the iceberg with the B100, but for the most part, I'd say that's one of the first things that we look at.
Okay, and the preferred pump sets and the polishers are rated for B100. We've taken all the rubber seals and things out.
Right. So we also, a 1,000-gallon tank or larger, that's B100, we probably would look at filtering that fuel as well.
Okay, a common question I get from engineers is, especially when they're doing a boiler system, they want to put a VFD on their transfer pumps so that if just one boiler is running rather than 3, they can slow down the pump and save a little bit of electricity. What's your recommendation on that? And is that allowed in New York City?
I think it's allowed, but I don't know if we've actually done it. I have not seen a VFD on an oil pump myself, and but I do a majority share of generator work, and we don't put VFDs on those pumps because they're typically 1 or 2 generators, and at that point there's really no cost advantage to having a VFD on it. Perhaps if you had a battery of generators and a common supply header, that might be beneficial.
John, we got a question in the chat just now. Can we use a heating oil, fuel oil tank to also serve an emergency generator?
So yes, if the tank previously held 6 oil, you can clean the tank, retest it, and have a new label put on the tank, and you can use it for diesel oil storage. The piping, though, I recommend be replaced because usually it's oversized piping because it was designed primarily around 6 oil. You had to move a lot of oil, and that pipe could have quite a buildup of old 6 oil on the inside of that pipe. So, and you would go from a 4-inch pipe typically probably down to 1 or 1.5-inch diameter pipe anyway with newer systems.
Okay, so in New York City, it's one set of transfer pumps per day tank or per gen set. Can you do a hybrid system where you're doing a boiler loop and connect a gen set to a boiler loop? So do boilers and a gen set on the same boiler loop?
Not recommended. There are situations where you might have surging in the line, and surging through a pump loop is not going to help the boiler's operation because if you're running a boiler loop and all of a sudden the day tank calls for fuel, the oil, you can't really dictate where it's going to go, but if the day tank is in front of the boiler loop, the oil is going to dump into the day tank. You might be able to put some kind of an orifice on that line and make sure some oil is feeding the generator loop, but for the most part, I would say you'd probably rather have them separate because if you've only got one pump skid and it's being used for the boiler loops, it's going to have wear and tear on it, and you really have to pay attention to its to make sure it's in good working shape and you don't want it failing out when the generator does call for fuel when you really need it.
You know, fuel systems have to be so different in New York City. I'm hesitant to answer any questions about New York City without talking about you.
Well, thank you. I appreciate it. It's been around a while.
Yeah.
You know, the good thing is New York City has a code, you know, extensive, 25-page code that you can at least review and get an idea of what can be done or what cannot be done. So that's, I'd say, you know, in a lot of other parts of the country, I don't think you even have a code as extensive as New York City has.
I really can't think of any other part of the country that has as many peculiarities in their fuel oil code as New York City. Are there things that you know to do that aren't written in the code? You know, things that the inspectors want to see that just hasn't gotten into the code yet?
Oh, that's kind of a tough question. Sometimes I know that there's a bulletin coming out ahead of when it's happening. I'd say one of the biggest issues is buildings are built according to particular years of the code. And what I can say is when the inspectors come in and the building may be being built to a 2014 code or even a 2008 code, and it's just taken this long, don't be surprised if the inspector tells you to bring the fuel system up to the 2022 code, which are some minor changes, but that I see a lot.
Okay. We have another question in the chat. What is the purpose of the fuel oil dog leg shown in the fuel oil piping schematic?
Okay, so that's the simple boiler loop. It's a low pressure loop. And what we do with that is it's a 12-inch high dog leg up, 12 inches over, then 12-inch back down onto your pipe and then returning to your tank. It's a low cost way to create some back pressure in your low pressure loop feeding your boilers. That's all it is. And, you know, takes the use of a valve out so that, you know, you don't have any failures in that valve and having a problem with your simple boiler loop. Be mindful.
That dog leg is also called a standpipe sometimes, right?
It's, I guess you could call it a standpipe, but it might have a breather on it too, just so that you can open a ball valve, let that primary, you know, on your primary startup, work the air out, and then you close that valve off and have a flooded loop.
Okay, I gotcha. So that's the end of the questions on the chat. We have about 2 minutes left, so I wanted to just shamelessly plug a webinar we did that actually never aired. We did a webinar on fuel oil systems for boilers that went straight to our YouTube channel. So if you go to YouTube and search on preferred utilities, you'll find our YouTube channel, click on videos, and it's just called Fuel System Design for Boilers. And I got a perfect example last week of something that we went over in that webinar. I was helping an engineer design a transfer piping system for 3 boilers, and he told me what type of boilers they were, and I went to the website and found the information on the boilers, and it had the consumption, or it had the flow to each boiler equal to the consumption. And then I know somebody at the boiler company, so I emailed him and asked what type of burners were going to be on these boilers, and he said it was Weishaupt. And my next question was, Weishaupt usually has an onboard pump, so the flow to each of these boilers is not going to be equal to the consumption, correct. And he didn't know, but he followed up by sending me the proposal for their Weishaupt burner. And I looked at the proposal, and the proposal included an onboard pump. And then I did a little bit of Googling and found the part number for the pump, and I found out that the flow through that pump was 2.5 times the consumption of the boiler, and we needed to bump up our transfer pumps to do that. But if we had just gone off of the boiler information that was available on the website, we would have put the wrong pumps in this system, and they would have been undersized. So go to YouTube, search on preferred utilities, click on the video tab, and you'll find all of our videos. And the webinar that John just finished will be up there in a couple of days if you want to review it or you want to recommend it to a colleague. So thanks, John, for doing this. It was excellent as usual.
I appreciate that. There's one last question I think we should address. It's a pretty good question. If my generator sits below the day tank, do I need an anti-siphon valve on the supply to the generator, or does a foot valve suffice? All right, so the New York City code states that you need an approved device, an anti-siphon valve, or a foot valve, and it's unfortunately a misnomer with this design of this equipment. I mean, this is a suction side device, this anti-siphon valve. So it's opening on vacuum, and when the pump stops, then the valve closes, and that's how an anti-siphon valve works. So it's going to prohibit that break in the line from siphoning this tank out on the floor. A foot valve actually opens on vacuum. So if a foot valve was used and that line broke, it could conceivably just dump all your oil out onto the floor. I mean, code says if one doesn't work, use the other, but I do not ever recommend using a foot valve as an anti-siphon device.
And Preferred just introduced anti-siphon valves with 4-foot springs just for this application.
Right, so I believe it's a 2 inches of vacuum would open the foot valve, the anti-siphon valve for generators.
Yeah, and they're pretty weak pumps they put on the gen sets, but they can typically pull 8 to 10 inches. So they definitely have enough pull to open up the anti-siphon valve.
Right.
Okay, if anybody has further questions, we're going to cut this off. Just email John and he would be happy to help you out. Thanks everybody again for attending.
Take care.